We're going to build an AI block generator using OpenAI GPT-4 and DALL-E 3 models for text generation and also image generation. We're going to use Supabase to store our blog posts, but also as a storage to upload our images. We're going to obviously use NextJs 14 for our front-end application. We're going to add authentication and user management using Clerk with some drop-in built-in components. And at the end, we're going to expose an API gateway so other developers can also use our APIs. Now, let me show you how this works, and then we're going to jump into the code and build this from scratch, step by step. Now, I've already generated some blog posts with images based on simple prompts here, for example. As you can see, some of which they're actually really valid blogs as you read through them. The importance of exercise, for example, very good points here. But let's actually create a blog here on the spot together. We need to be signed in. So I'm going to click here. This opens up a modal for us to sign in. This is a drop-in component from Clerk. I'm going to select my account. I'm going to be redirected back to my app, this time signed in. I have this user button, which is going to give me user management. We're going to see this in action later on in the video, step by step. But let's actually provide a prompt here. Let's say Tesla trucks. I've never tried this before, so let's see how this turns out. Now, what this is going to do is going to send this prompt to OpenAI GPT-4 to generate a blog post. It's going to then provide that blog post to the DALL-E 3 model to generate an image that suits this blog posts. It's going to then upload this image to Supabase storage, get a URL back, and save this blog post to our Supabase database. And then once all of this is done, it's going to redirect us back to that specific blog post page where we can read the blog and see the image. That's through Next.js server actions, which we're going to dive together and see how it's done. And we have our blog post ready here with the image that was generated and a about 200 word blog post over here. Now, when we go back, we should also revalidate the path or the index to see this blog post that was just generated here inside of our homepage. We're going to start with a high-level architecture of our application and the different pieces of technologies that we have. We're going to then move to the backend, set up our Supabase database. We're going to then move to the Next.js frontend and connect the two together. We're going to add authentication. And then at the end, we're going to add the API gateway through Zuplo that allows us to also expose this functionality to other developers. So let's just start from the architecture. From a high level, we're going to have Supabase as our backend for database to store our blog post, but also as a storage so we can upload images that is coming back from OpenAI into Supabase and get a URL back. Now, our front-end application is also Next.js. We're going to first create a server action that talks to OpenAI directly to generate these texts and images and then save this up into Supabase. Now, at the end, we're going to add an API gateway using Zuplo that allows us to expose this API to other developers so they can sign up, get an API key to authenticate, and send a prompt to get a blog post with an image back. So instead of having to write all of that logic inside Next.js server-side or server actions, we're going to move that logic to our API gateway or the API layer to talk to OpenAI, to generate these blog posts, talk to Supabase, and then return the blog post to whoever it's calling actually our API. It may be our own front-end Next.js application or other developers. So with that out of the way, let's just move to the backend. I created this list so I can keep track of everything that we need to talk about, so I'm not going to miss anything. So the first step in creating our backend, which is going to be a Supabase, is for you to create a Supabase account if you don't have already. Create a project, and we're going to then create a blogs table with the following columns. So every blog post is going to have an ID, a created at time, which we can use to then sort these blog posts. A title, this is going to be the prompt that the user have submitted. Now the content is going to be what's returned from GPT-4 text generation. The image is going to be what's returned from DALL-E 3, and the user ID is the authenticated user inside of our front-end application actually making this request. So let's go to Supabase. I've already created this, but let me just show you how it works. So once you sign into your account, you can go ahead and create a new project here. I've already done so. Once you're inside of your project, on the side table here, you can see this table editor. You can go ahead and create a new table, give it a name. I've named mine blogs. And then down here, you can add your keys, the ID, and created add fields are already added here for you. You can just go ahead and add the title, the content, the image, and the user ID, all of which are of type text or string. And then once you've done that, you could just click save, and then your table would be ready. I've already created this blogs table with the same fields and already have some content over here. So that's the first step of creating our table. Now we need to create a new storage bucket and make it public. This is going to be for us to upload our images that are returned from OpenAI. So going back to our Supabase account, we can go down here to storage. You can go ahead and create a new bucket, give it a name, and make it public. Making your buckets public would allow other users to read objects from your bucket without any authentication, but they will still need to authenticate if they wanted to upload or delete any image. Now, this is going to help other developers who are using our API through our gateway to be able to use the image URLs that we are returning from our Supabase storage. I've already gone ahead and created a blogs storage as well, and I have a couple of images that was generated from DALL-E already and stored inside of my database. With that out of the way, let's go back. So we have already completed this. So let's close our backend. Now let's jump into the frontend NextJS application. So you can go ahead and create a new NextJS application or use the starter template that I've included in the description. So this is going to be a NextJS starter template, which is going to take you to this repository. You could just click on this, use this template. It's basically using TypeScript, Tailwind CSS, and some prettier plugins. I do have a video on the channel where I talk about how I set up my NextJS applications. I'm going to include that also in the description so you can have a watch there. Now, once we have done this, let's go back to our list. So we have created our NextJS app. As I mentioned, I've already done this. I have my NextJS app running on localhost. So let's open this up. And all I had done is to replace the content of our homepage to this Next AI Blogger. Nothing else has been added, and we're going to build this from scratch together. So we have created our NextJS app. Now, next step, we're going to use ShatCN UI library for some components. So let's add this to our project. Inside of the docs, you can go to installation, Next.js, and then you can run this command. If you're using NPM or NPX, you could use it, or copy whatever package manager you're using. I'm using PNPM, so I'm going to copy that code. I'm going to then stop the dev server, copy this code, and then initialize ShatCN. This is going to install Radix UI, which is what ShatCN uses behind the scene, and some other dependencies. It's going to also help us set up our application. So it's asking for the style. I'm going to choose default style, CSS variables. We're not going to use CSS variables or theming for this application. You can go ahead and use it if you are actually using theming in the application. Okay, it seems to be done. So let me just restart my dev server, close this page, and go back. Now, as you can see, running the script has modified my Tailwind config by adding some animations and keyframes to it. It has also added this components JSON, which tells ShatCN the structure of our application. Inside of this lib, we have this CN function that uses Tailwind merge and CLSX package to sort and merge our Tailwind utility classes when we're using ShatCN component. We also have this components folder where we're going to add our UI components as we move on. So let's go back to our list. We have added ShatCN to our project. Now let's create a Supabase client so we can talk to our database. Now, to be able to do that, we have to set some environment variables. So let's just close this off, go back and create a .env.local. And now here we need a Supabase URL. So I'm going to copy this here. And then we need a Supabase service key role. So let's also copy this here. Now I'm going to also create an example file here. So let's go ahead and create a .env.example where I'm going to show everything that we have to create over here as well. Now, to get these values, we need to go to our Supabase account. Inside of our settings, we can go to API. Here we have the project URL, so you can copy this over here. That's our Supabase URL. And then down here, we can see this service role key. This is a secret key. You should not expose this to your front-end application. So you can copy this and bring it to your .env Okay, I've copied my secret key. Let's go back to the next step. So we have set our environment variables. Now we need to create a client and add some functions that talks to our database. So I'm going to create a file inside of our lib folder. I'm going to name this supabase.ts, and let's copy some code, and I'm going to explain what we're doing here. Now, before I go ahead, we need to install the Supabase.js package. So let me just stop the dev server here and then pm add Supabase.js. This is going to allow us to create a Supabase client and talk to our database. Let's restart the server, come back here. Now here, we're using this create client function from the Supabase package, passing in our credentials to create a Supabase client that allows us to talk to our database. I then created two simple functions, the get blog by ID and get all blogs. The get blogs by ID gets an ID of type number. It then connects to Supabase using this client and selects from our blogs table a row that has the ID equal to this ID that I'm passing in and returns the single or returns that specific resource. And then the get all blogs function is going to use Supabase to connect or fetch all of the resources inside of our blogs table, and it also sorts them or orders them based on the created add field. So these are the functions that we need inside of our application. So let's move to the next step, which is our application shell, which is basically adding a header component. So let's go back. I'm going to close this, go back to our application, open up our app router. Inside of our layout, this is where our root layout lives. We want to add a header component. So let's go ahead. Inside of our components, I'm going to create a header component.tsx. So let me copy some code here and explain what we're doing. So I'm creating this header component and a div with a container and flex. We're going to render a logo and a sign-in button. Now we need to create this button from ShatCN. So let's go to our ShatCN, scrolling down to the button here. You can just go ahead and run this command to install or copy the code for the button. So let me just go ahead and do this. I'm going to stop the dev server again and then copy this code. Let me restart the dev server. We also need to create a logo component. So let me just go ahead and inside of our component, create this logo.tsx, which is basically some SVG logo component that we're just rendering here. Now we can go back to our layout and bring in this header component. Let me close this up inside of here so I can have my header component, and then I can wrap the rest of our app inside of this main tag. So let me just cut this out and bring it here. And that's all I need for now. Let's save this up, go back to our application. Let's refresh the page and we should be able to see the header component up top. There you have it. We have our logo and also our sign-in button. Pretty straightforward. So let's go back to the next step. Now we want to work on our homepage. So let's close everything here and go to our homepage. So here we want to add a form component that is going to allow us to take a prompt or an input from the user to then talk to OpenAI. So let's go ahead and create a form component inside of our component. I'm going to add a form. So let me copy this code over here and see what we're doing. So we're using the card component and input, just rendering a section, and inside of a card component, we're going to have a header. So we have a title for our card and some description. And then inside of the card content, again, this is a ShatCN component. We're going to look at it in a second. I'm rendering a form with an input that takes in a prompt or a text input from the user and then a submit button to actually submit this to our backend. Now let's go to ShatCN and install the input and the card component. So down here we have the card component. This is going to render a simple nice card. Go ahead and copy this command from here. Let me just stop the dev server. I'm going to copy this code. While that's done, let's also go to our input component and bring in the code for installing our input. So I'm going to select the pm code again here too. Just clear this out and restart our dev server. Now going back to our application, we should be able to see that form popping up here. Now we haven't brought the form back inside of our page. So let's go ahead and actually import it here. So we're going to say form. And now if I save and refresh, we should see this form popping up here. Now let's go back to our form down here. Now to handle this form submission, we're going to use a server action, which are now stable in NextJs 14. So instead of the traditional way of creating an API endpoint and then adding an event handler to this form to submit the data to our API where we can talk to OpenAI models and our database. We're going to accomplish all of that with use of server actions without having to create that API endpoint. So I'm going to create a client-side action from where I can then call my server-side action. This is going to allow me to handle errors. So let's go ahead and create an async function. I'm going to call this action. This is going to receive form data by React. This is of type form data. And then from inside of here, we're going to say prompt equals to calling this form data.get. And I'm going to pass in the prompt. This is going to map to the name attribute that we have set on our input. Let's add a simple validation here. So if there is no prompt passed, let's just show a toast notification. So let's go ahead and bring in the toast component from ShadCN that's using Sonar. I've actually talked about this before on the channel. So this is a very nice notification that you can use. All you need to do is to run this command, which is basically going to add Sonar under the hood. Then you need to add this toaster provider to your layout. So you can just call this toast function later on to show this toast notification. So let's just go ahead and add this one too. I'm going to pause this and then we're going to add that component. So let me clear this up and restart the dev server. And now we have to add this component inside of our layout. So I'm going to go to my layout. Let's just import the component up top there. And now down here, I can just go ahead and copy this toaster component or provider inside of my body tag. I've already passed in some options. So a position top right, this is going to show the notification on the top right corner. I have a theme for my notification and I'm using the rich colors. You can go through the docs. There's actually a link to the original docs from this component from ShadCN that you can see other modifications that you can make to your toast component. Now this is going to allow me to call the toast function to actually show the toast notification. Let me also import this toast function from Sonar up top. Now that we have this basic simple client-side action, let's pass this to our form. So inside of our form, we're going to pass this to an action prop. We're going to set this to this client-side action. And then from here, if we do have a prompt, the idea is to call our server action, which only runs server-side where we can safely connect to our database or talk to OpenAI models. So let's create this server action next. So let's go inside of our app router. I'm going to create an actions.ts file where we're going to use the use server directive. This is going to instruct NextJs to only run this code on the server, where we're going to export an async function. I'm going to call this create completion. This is going to expect a prompt of type string. Let me just close this off so we have more room over here. Now again, I'm going to check to see if I have no prompt. So a simple, again, validation here. I'm going to return an object with an error property that says prompt is required. Now, as a side note, you can return any serializable object from your server actions, and that's how I'm handling errors in this case. So now that we have this create completion server action, well, kind of, it's still incomplete, but let's go back inside of our form and actually call this function here. We're going to destructure the error from it. It's an asynchronous function, so I'm going to await and I'm going to call this create completion that we just created inside of our actions, and it does require a prompt. Okay, so we get this prompt that we created here and pass it down here. Now this prompt is coming in from our form data, and to make TypeScript happy, I'm going to pass as a string here because this prompt technically can also be a file. Again, from the form data inside of your file, you can have an input of type file. This is to say we know this is going to be a string. Now from here, if we do have any errors, I want to show a toast notification again. So toast.error, and I'm going to just pass this error out. So let's just save this up. And if I remove this check over here, so we're not checking inside of our client-side action whether or not we have this prompt, we're going to call our create completion server action. This is going to take that prompt and check to see if we have it. And if we don't, it's going to return that error. So with this going back to our application, if I go ahead and refresh the app and submit this form without any prompt, I'm going to again get this toast notification that says prompt is required, but this time this is coming in from this error message that we returned from our server action. Okay, great. So let's continue moving on. This is where we would want to actually generate a blog post using OpenAI. And then we would also want to generate an image, again using OpenAI. We would then need to upload the image to Supabase storage. And from here, we're going to create a new blog post in Supabase using the information that's returned from OpenAI. So let's go ahead and open the OpenAI documentation. There's an introduction and a quick start guide where you can understand how to use the SDK to talk to different endpoints or models in OpenAI. You can also come down to this text generation tab where it explains different models that you can use in OpenAI to generate text. And there's a little code snippet here for using the OpenAI SDK, which is a wrapper around their API or REST endpoints. For example, here we can use this chat completion endpoint to create or generate text based on these messages or prompts that we pass in and the specific model that we want to use. So let's go ahead and install OpenAI SDK. So I'm going to stop the development server here and pm add OpenAI. Let me clear this out, restart the dev server, close this up. Let's create our OpenAI client here. So we're importing this OpenAI from the package we just installed, and using it, we're going to create a new client. We have to pass in an API key, and we're going to use this client now to talk to different endpoints in API. Now, to get your API key, you can just go back to the documentation here on the settings tab or on this sidebar. You can see these API keys. You have to go there, create a new API key if you don't have to, and then bring it back to your .env.local. And this is what I'm going to do here. So I'm going to open this up, going to the example that we have. So this is another API key that we need to provide. Okay, so I've copied my API keys. Now we can use this OpenAI client to generate some text. So let me copy some code and explain what we're doing here. We're using our client to hit this chat completions endpoint. We need to pass in an array of messages here that have a role of whatever the role is. It can be a user or the assistant or the system. When we are sending messages, it's either the user or the system. The system is used if you wanted to give some instruction to the model, in this case GPT-4, and then the user is actually the prompt that the user plugged in, and the assistant role will be the response that comes back from OpenAI. And if we have any completion and the content inside of it, it's going to be stored in this content. If not, we're going to again similarly return an error object with this error. Now let's also go to the image generation. You can see here we can use the same client that we created, and this time we're going to hit the create image endpoint to generate some images using the DALL-E 3 model. So let me just copy that code over here as well. So in the next step, you're creating an image. And the prompt this time is to generate an image for a blog post about the same prompt that we are getting in from the user, same prompt that we used to generate a blog post. We are specifying the model. N is this number of images you want to the model to create. It's 1. You can pass in a size, and there are 2 different response formats you can get back from OpenAI. As I just briefly mentioned in the beginning, you can get a URL back, which expires after, I think, an hour. Or you can get the raw data image, which then you need to upload to your own storage. So it just stays there forever. And then you would store the URL to your own storage in your database. So I'm getting the image data out of this base64 JSON response. And if there is no image data, again, I'm returning an error object. So now that we have the image data, let's actually go ahead and upload this to Supabase. So I'm going to use Supabase storage. Again, we're going to use the Supabase client we created earlier. So let me just export this from our library. You can actually upload a file in 2 different ways. One way would be the file that you get back from a form submission. Let's say you have an input type file inside of a form. You get that form data back. You could just pass that file from your form data to the upload function of your Supabase storage. The other way is to pass in an array buffer, and this is what we're doing here. So if we're using this decode function, we're going to install a package that does this for us, which decodes a base 64 raw image into an array buffer, which we can then use to upload our image to our Supabase. Now, going to Supabase documentation for a second here, if you scroll down to client libraries, this JavaScript library is the one that we are using here. Scrolling down, you would get to the storage, and here you can upload a file. Now, you can use the Supabase storage, as I mentioned, to upload a file that's coming back from a form submission. As you can see here, event.target.files with a specific destination and a name. But you can also use this upload functionality to pass in an array buffer, which you're going to decode out of the base 64 raw data that we're getting back from OpenAI, and then pass this into that specific folder and this name or destination. So that's exactly what we're doing inside of our code. We just need to install this base 64 to array buffer package that helps us just do this decoding. So let's stop the dev server and pm add the package. Let me clear this out, restart the dev server. I'm going to copy this line and bring it all the way up here, so I have access to this decode function. Okay, so we've gone ahead, decoded our image, the raw data that we got back from our OpenAI endpoint. We're going to upload that to our Supabase storage, and we're going to get the data. Now, this data is going to have the path where we have actually stored our image inside of our Supabase storage. So from the data, we're going to get the path, and we're going to reconstruct the image URL where this image actually lives in our storage, so we can access it or read it from this URL. So we're getting the Supabase URL. This is our project URL, and your images would live at storage version 1 object public. Blogs is the name of my bucket, and then that specific path, which refers to this image we just uploaded here. Now that we have this data, we can actually go ahead and insert a new blog post into our Supabase table called blogs. We're going to insert a new object or a new resource with the title. That's the prompt, the content that's returned from GPT-4. The image URL is what we constructed here, coming back from our storage, and then the user ID, because remember, our table is supposed to have a user ID, but at this point we don't have any authentication, so I'm just going to pass a string of 1 to 3 here, so we have the required fields. Next, I'm going to call this select function, so it returns this very inserted row back to me. So I have the blog data here, or an error. Again, similarly, if I have an error, I'm returning this object. And if you go back to our application and test this out, let's refresh the page, everything should work. Let me also open the terminal so we can see the response coming back. So I'm going to say, let's say generative AI, and see what this says. So I've gone ahead and submitted the form. Right now, there's no indication for us to know if this has been submitted or not. We just have to wait for this to go ahead and log something inside of our console here. So we got the response back here. As you can see, I have this blog post inserted with an ID created at, and the content in the format of Markdown. I have a title, a user ID, and then the image URL that points into our storage in Supabase. I'm also getting this error here that we're trying to destructure error property of something that doesn't have any value. So our server action is not returning anything once it is completed. I'm just logging in here. But inside here, I'm just destructuring error out of an undefined response. So maybe we can just name this result. And then down here, we can check to see if result exists. And if there is any error on it, then we can actually log that or show that inside of our toast notification. So we won't have this error. But we also want to improve this user experience where we would just add something here for them to know that they have submitted their form. So let me just close this off so I have more space down here. So going back inside of our form, down here where I have the submit button, I'm going to extract this button into its own separate component where I can use this use form status hook from React DOM. Use form status and use form state are two new hooks you could use with your server actions when you're handling your form submissions. One is to handle the form state, and the other one is to handle the loading status or the pending state of your parent form. That's why you need to have this inside of a separate component, because this hook is going to tap into the parent form. I have a video on the channel where I explain use form status and use form state hook and actually tie that in with server actions in Next.js. So I'm going to link it somewhere in the description or above in the cart. So you can watch that video if you don't know this hook. But it basically is going to give us a pending state. This is when our form is being submitted. Let me just also import this CN function. And all I'm doing here is if we are in a pending state, or if this server action is still working, we haven't had any response back, I'm showing a different text. But I'm also using Tailwind CSS to animate this button so the user at least knows that the form has been submitted and we're working on generating this blog post. So now I'm going to just swap this button with this submit. And now my form is going to have some loading state. Now going back to our action, once we get this blog back, ideally we want to send the user to that specific blog ID. So let's get the blog ID here. Let me just comment this out or delete it altogether. So we're going to get the blog ID out of this blog object that comes back from Supabase. We're going to extract the ID out of it. And we want to redirect the user to /blog and that specific blog ID so they can see the blog post that was generated for them. Now let me also import this redirect function from Next Navigation. And now we have to create this dynamic blog page. So let's create a blog, and inside of it we're going to have a dynamic ID, and then inside of it we're going to have a page.tsx. Let me copy some code and explain what I'm doing here. Now inside of this dynamic blog page we are receiving the params object from Next.js. These are going to be the dynamic parameters in the URL. We're expecting an ID because we named this dynamic route an ID. We are receiving that ID, we are passing it to the get blog by ID function we created in the beginning of tutorial, which we are using a Supabase function to just select a specific ID or a specific row with this ID. So if you're getting that specific block, we're destructuring the content and the image URL. The content is what came back from our GPT-4 model. Same for the image, and we're using this markdown component to render this content because we asked for a markdown content back. So I'm using React Markdown, which we need to also install to turn this into something that React can render. And then we're using the image tag to render our image URL. This is the URL to the image that lives on our own storage, and we have a link here to just go back to the index page or to our home page. So let's go ahead and install the React Markdown. Let me just stop this and then pm add the package. Let me clear the deck and restart the dev server here. Let me close this up. And if we now go to our Supabase database, inside of our table, we see this last row that was the generative AI title is created here, and it has an ID of 28. So going back to our app, if I now move to /blog /28, I should be able to see this post generated here. Okay, that resulted in an error. We have to define this host name, which is our Supabase project URL, inside of our next config for next image to work properly. So let's go back inside of our project. Inside of our next config, we're going to add a remote pattern to our images. There are different options you can pass in here, but basically this is going to define this remote pattern safe for Next.js to fetch or serve our images. So let me just go ahead and stop the development server and restart it for this to take effect. If I now refresh this page, we should be able to see our blog post. And here we go. We have the image and also the content of our blog post. Now, the content is not styled properly because I have to install the Tailwind typography package. Just to show you what I'm doing, let's open up Tailwind. You can go to the docs and search for typography. This is a plugin you can install that allows you to pass in this pros class to any parent element. For example, whenever you're having a markdown file that you don't have access to style directly, you could just wrap it inside of a parent with this pros class. This is going to automatically apply some Tailwind CSS to your markup. So let's go ahead and actually install this package. So let me stop the dev server here, pm add, and then as a development dependency, if you're installing that. And once you do that, you have to also pass it into your Tailwind components or Tailwind plugins. So let's go to our Tailwind config over here, and we can also pass this typography. Restart the dev server. Let me close this back and go back to our application. And once I refresh the page here, we should be able to see Tailwind styles applied to our markup. There we have it. Now, sometimes the content that we're getting back from our GPT model actually has some front matter, because I have asked it in the prompt that I want the content of my blog post back in Markdown format. It actually goes ahead and provides some front matter to it too. You can be more precise and play around with the prompt, so therefore it doesn't have any front matter, or you can scrape this out of your content before passing it down to this Markdown component. But for now, I'm just going to leave it as is. Now, going back to our homepage, let's actually add a recent blog section where we're going to fetch all of the generated blogs and show it down here. So let's go back to our homepage, and inside of this section, I'm going to add this div where I am going to fetch the blogs using the function we created in the beginning and some card components to show our recently generated blogs. So let's go ahead and import what we need here. So I'm going to import the card component from chat.cn for the blogs. Let's actually go ahead and fetch our blogs over here. So I'm going to say const blogs equal to await, calling the get all blogs function that we created in the beginning of the tutorial. I'm going to turn my function into an async function. Again, server components can be turned into async functions. You might have already known that by now, so that you can just fetch inside of your React server component. And now I need to have the next link. I'm going to explain what we're doing here in a second. Let me just import this component from next image. And now this format date is a function that I'm going to create that formats the date that was this blog post was created. So inside of our lib, I'm going to, inside of this utils, I'm going to add a function that just takes in a date string and formats it in a nice way. So let's close this up. Going back here, I can now import this format date from our lib. So let's save this up. So what we're doing here is inside of our page component, we're calling this get all blogs function, getting all the blog posts. And now down here, I have this recent blog section where I'm getting all the blogs, mapping over them. And for each one, I'm rendering this card component from chat.cn. I'm including a link that takes me to that specific blog ID individual or dynamic page. I'm showing the blog image and then the title of the blog and also the date it was created. So as you can see here, this is populated here. This is our most recent generative AI one with the date and also the rest of the blog post that I have generated before. So let's test this end to end one more time. Let's generate a blog about, let's say, JavaScript. Now immediately this turned into working on it, and with the animation that's using the use form status hook, we hook into the parent's form's loading or pending state. This improves the user experience because then they now know that we have received the request. We're working on generating the blog post. Once the blog post is generated, we are now redirected back to that individual blog post where we have our content as well as our image. But watch what happens when I go back to our homepage. Now back in our homepage, we don't see this recently generated blog. This is because inside of our homepage where we are fetching this blog, we are using a server component. This is cached by default. So we are serving up the cached version of this page. And we do not have that most recently generated blog post. Now, to get around this or to fix this inside of our action, when we're actually creating this blog post, before redirecting, we're going to use the revalidate path function from NextJs and revalidate the cache for the path, which is our index, our homepage. So therefore, it refetches our blog posts from Supabase and re-renders this page. So we always have the most recently generated blog post. So let's save this up. And with this, if I just refresh the page, we should be able to see that lastly generated blog post. There we have it. Now let's test this one more time. I'm going to say TypeScript this time. Okay, great. So we see our blog post created here with an image, also with a title and some text content. And now if I hit back and go back to our homepage, we should be able to see that TypeScript blog also created here because we revalidated the cache for our index route. This is going to rerun the page component, which is then going to call this function again, fetch the blogs from Supabase and re-render this page. So we have the functionality of our app working, But right now we don't have any authentication. So anyone can come in and hit this endpoint and start generating these blog posts. Now, what I want to do is I want to protect this form submission behind authentication. I still want users to be able to come to homepage or go to one individual blog post. But if they want to go ahead and generate a blog, I want to protect this behind authentication. And for this, we're going to use Clerk. Now, Clerk is an authentication provider for React and Next.js applications. It has built-in drop-in components that you can just drop into your app and easily hook your application with Clerk backend. So I'm going to sign into my account. Once you create an account here, you can go ahead and create a new project. I've already done so, but once you create a new project, you're going to be landing in a similar page like this. You can go ahead and copy your credentials to your environment variables in your Next.js app to be able to connect to Clerk. And from here, you can just click on this button. If you're selecting Next.js up top as a library, you can continue to the docs where it walks you through simple steps for you to be able to connect your Next.js app to Clerk. Let me make this a bit bigger. So we need to install the Clerk Next.js package. Let me go ahead and select PNPM, and I'm going to copy this. Coming back to my application, I'm going to stop the dev server and paste this code in. Now, the next step is to set your environment variables. If you have logged into Clerk, this is going to populate down here as well. So you can copy it from here to your local environment variables in Next.js. I've already done that. So the next step is to wrap your app in a Clerk provider component. This is a context provider. So Clerk hooks can access the session data. So what you need to do inside of the app router, you can just bring in this Clerk provider component. So let's go back to our app component. Inside of here, we have the root layout. And now here I can import this component. And all we need to do now is to wrap our entire app with this Clerk provider. So let's come down here. What I'm going to do is I'm going to come inside of here and say Clerk provider. I'm going to close this off and wrap my body with the Clerk provider. Now, one thing I want to mention, let me just close this off. Now, typically with this provider patterns, when we are sharing React context inside of the app router, we provide this provider's client component where we can use React context because it's a React hook. You would need a client component for that matter. And then we bring in that provider into this file and wrap our application or root layout with that providers. Now for Clerk, they've already done so. So this is internally a client component that's using React context that now wraps your app. So you don't need to have the workaround of creating your own client component because this is already done. So you just need to import it directly into your server component, into your root layout, and wrap your whole application, your whole HTML, or in this case, the body tag with this Clerk provider. Now, the next step is to add a middleware to then require authentication and pass in what paths you want to be protected or not. So you can add in a middleware to your Next.js app using this auth middleware function that comes back from Clerk. You can then decide which paths you want it to be authenticated. So let's go ahead and inside of our root layout, I'm going to create a file called middleware.ts. I'm going to copy some code here. Let me explain what we're doing here. Now, this auth middleware by default, if you don't pass it any option, is going to protect all of the routes and pages in your app. But this is not the case for our app. I want users to be able to go on the homepage. I want them to be able to also visit individual blogs that have been generated by others. I just want to protect that form submission where a user wants to generate a blog to be protected. So therefore, I'm passing in this option where I'm saying my public routes needs to be basically everything. Now, you can go to this middleware reference page to see what options you can pass in here. So the default behavior, as I mentioned, is to protect all of the pages, but you can exclude some pages as public routes from this auth middleware. You can pass in an array of paths. For example, here it says the homepage and the contact page should be public. It still runs this middleware on all of the pages, so you have access to the session object and whether or not the user is logged in on all of the pages, but it's not going to protect these two pages against or behind authentication. You can also pass in locale, so you can read through this for more information. I do also have another video on the channel where I dive deeper into Clerk if you want to understand different options. I'm going to link that one also in the cart so you can dive deeper into Clerk. But you can see down here, we also have this example where we're looking at the request URL to see whether or not it includes the word or / dashboard. If it does, we are returning false over here, which just makes this path protected and anything else public. But in my case, I wanted to make everything public, so I've just returned true from this public route. There are different options or different ways you can do it. This is just what I came up with. The config matcher, this is for middlewares in Next.js. Generally speaking, you can decide or match the paths you want this middleware to run on. This is going to run on every path besides your static pages, your _next. And it is going to also run on the API gRPC routes. So you can pass in different types of matchers, different regular expressions here to instruct Next.js for what routes you want this middleware to run. Okay, so let's go back to the previous page. We have added our middleware. Now the next is to actually provide some of this drop-in built-in components from Clerk, such as this user button or sign-in button, that gives the user a way to sign in and sign out and actually access their profile. So let's go back to our application. Let me close everything off. And now I'm going to go to my header and I'm going to actually replace this with some Clerk components. So now I'm using this component from Clerk to render a sign in button if the user is signed out and a user button if they're signed in. Now let me explain these two components. We have this signed in components and signed out components. This is called control components in Clerk. It just renders the content of whatever you pass to it. In this case, if the user is signed in, and here if the user is signed out. Now going back to the Clerk documentation under this 5th step, we have a link to a set of pre-built components. These are drop-in components from Clerk you could use in your application. There's UI-specific components such as the sign in and sign up components. This is useful if you wanted to create your own custom sign in and sign up page. Actually, if you go back to the same guide and scroll down, you can see another guide that walks you through creating custom sign in and sign up pages. And basically, you need to create these different routes and drop in this sign up and sign in component. And now you have a custom sign in and sign up page. Now going back to our pre-built components again, we have some control components such as this signed in and signed out. This is to conditionally render different components depending on whether or not the user is logged in. We have the sign in button, which allows the users to sign in. And we have some user specific components down here, such as the user button or user profile. The user button is going to allow the user to manage their profile or sign out of our account. And all we're doing here inside of our app is you're rendering a user button if they're logged in and a sign in button if they're actually signed out. Now this sign in button by default is going to redirect the users to your sign in page, but you can also pass in a mode of modal, which is going to open up a modal instead of redirecting to a different page. And again, by default, it's going to render a button, but you can pass in any children that you want to this sign in button here. I'm just passing my chat CN button component so that it looks the same as other components in our app, or that I can have control over how I want to style it. Now, if I save this up and go back to our application, we should be able to see this sign in button there. But this time our sign in button is actually hooked up with Clerk. So if I click on it, it's going to open up a modal for me to be able to log in. And if I go ahead and log into our service, it's going to redirect me back to the application and show this user button. This is this show user button that we are showing here conditionally with this signed in control component. If I click on this, I'll be able to manage my account. This is all done with Clerk. It's a beautiful UI for users to manage their profile. We can also sign out of our account. Now, the last step in our authentication is to protect this form submission from unauthenticated users. So let me close this off and I'm going to go back to my form where I'm rendering this submit button. Now, instead of having a submit button all the time, what I want to do is I want to use Clerk components. So let me just also import this sign in button from Clerk and sign out control component from Clerk, and also this one. So let me save this up. Now, if you're signed in, I'm going to render a regular button of type submit that allows you to submit this form. But if you're signed out using this control component, I'm actually going to render a sign in button from Clerk. So this is not of type submit, it's of type button. And this is important to set because if you don't set it, by default, any button would be type submit. And then it is going to submit the form instead of opening up our authentication model. So if you're signed out, I'm just showing Clerk's sign in button. So let me just go ahead and log out here. Now this button sign in to start is going to open up the same model, so it's not going to submit our form. So it's going to protect this form against unauthenticated users. But what we can do to further protect our endpoint against unauthenticated users is to go inside of our app and our action and actually check to see if the user is authenticated inside of our server action. So I'm going to import this auth function from Clerk. And I'm going to use this auth function down here inside of my server action to return if the user is not logged in. Now this auth function is going to return an authentication state that has the user ID on it. So we can check to see if there is a user ID, they're authenticated. If there is no user ID, we're going to return this error that says user needs to be logged in. Now we can then use this user ID to pass it down where we were creating our blog post here. So we no longer need to pass in 1, 2, 3. Now we can read the user ID from the authenticated user. So let's save this up and refresh our page. Now our endpoint is fully protected behind authentication. On the client side, we swapped this button with Clerk sign in button. So it opens up a modal if the user is not logged in instead of submitting the form. And on the server side, inside of our server action, we checked whether or not the user is logged in using this auth function from Clerk. Okay, so now let's go back to our list and see what we have done. So we've created the homepage, the form component, client action, server action. We have installed OpenAI. We have made the call and added the block ID, the redirect, the revalidation, submit button, toast component, recent block. So we've done all of that. Let me just close this up. Inside of our authentication, we've completed all of these tasks. Now in the last step, we want to add an API layer that exposes this functionality to other developers to use our API, for example, to hit our endpoint, provide a prompt, and get a blog back. Now, the functionality we have here is rather simple. It's just generating a blog, but you can imagine that you have more, you can add more, or have more complex AI features that you can then expose via an API for other developers to use. Now, going back to our architecture diagrams from the beginning of the video, what we want to do from a high level is to add this API gateway that sits like a middleware in between our Supabase backend and any front-end consumer of our APIs. Now we're going to move the logic of talking to OpenAI models and talking to the database to this API gateway that's deployed as a middleware to the edge. Now this is going to be the only authenticated party to talk to Supabase and talk to our OpenAI account. And all the other front-end consumers, such as our own NextJs app or any other developer for that matter, they can sign up, get an API key, authenticate against this gateway, and use our APIs. Now, as I mentioned, we're going to use Zuplo to implement this. So let's open up Zuplo. Zuplo basically gives you an easy way to add API gateways. It's very easy to add authentication, rate limiting. With just a click of a button, you can add policies to it. I do have a video on the channel where I dive deeper into how you would set Zuplo up. So let me log into my account so I can show you the dashboard and specifically this project that I have created before. I'm not going to start this project from scratch. Again, if you want to learn this or if this of any interest to you, you can just watch that video. I'm going to link it in the card somewhere where I walk over what Zuplo is and how you would go about implementing it. I'm going to show you what we need to do here to just deploy an API gateway that sits in between our front-end consumers and our Supabase backend. So basically, once you create a Zuplo project, you're going to have an endpoint instantly. For example, here, this is my endpoint that anyone can use now to access my APIs and the functionality that I'm exposing through these APIs. And I do also have a developer portal automatically created for me. So let's just visit this together. Now, this is all generated automatically for you when you define your routes. And I'm going to show you how we can define our routes. Specifically, in this case, we're going to define a post route for developers to submit a post request to our endpoint, pass in a prompt, and get a blog post back. But you can see here, I have a create a blog AI endpoint. Let me just make this a bit bigger. if you can see down here, this is a post request to /v1 blogs, and I do have my endpoint, the base URL up there. It also tells them that you need to be authorized. You need to pass in a request body. It has to have a prompt and it has to have a user ID. It's going to tell you what the example body would look like or an example response. So all of this is created automatically for you once you create a route in Zuplo. Now, the way you create routes in Zuplo is inside this route.oas.json. This is based on OpenAPI specifications. So here I have created a route. It's a post route. Let me just make this a bit smaller so that you can see the full page. So inside of this, I have created a summary. This is the path, v1 blogs. The method is post. You can define different course policies. Now down here, to handle the request, you have different functionalities defined. You can forward, rewrite, and redirect to different URLs, or you can run a function. This is what I'm doing here. So I am defining this generate blog module, and any request that comes into this endpoint, I'm just returning or executing this function. So let's see what this function does. So inside of this modules folder, I've defined a couple of modules. This generate blog is basically our server action. So what I'm getting is a prompt and a user ID. I'm going to call the chat completion endpoint from OpenAI, and I'm getting the OpenAI from this OpenAI module that I've created, which is going to call this OpenAI client and pass in my environment variables or my credentials. And then I'm going to do the same thing with the image generation. So same thing that as we had done inside of our server action, now we are doing it inside here, which is deployed to the edge, the same runtime as your middlewares run in NextJs. And once I have the data returned back from my GPT models, I'm going to store, again, it's a bit small, I apologize. Let me make this a bit smaller, it just goes off a screen. So let me just do this. Again, once I have my image back, I'm going to upload this to Supabase. And then once I have the image uploaded, I'm going to go ahead and actually create this blog. And all I'm doing here is to return this saved blog post back to the color of this endpoint. So let's go back here. So this was our generate blog. Again, the OpenAI is to create our OpenAI client. The Supabase module is to create our Supabase client. And this decode is the same decode function we had to run to convert a base 64 image to an array of buffers so we can upload it to our Supabase storage. So going back to our routes one more time, let me just go here. So a request comes in. I'm taking in a prompt and user ID in the request body, generating this blog post, uploading it to my own backend, and then sending the blog back to the caller of this ID. Now you might think, well, anyone now can call this endpoint. It's not really authenticated or protected against behind authentication. Well, this is where Zuplo's power comes into play. In this policies tab, you can just easily add policies. For example, I have added this rate limiting policy or API key. So if you go to add policy, there are different policies you can add here. For example, you can add API key authentication. This requires the incoming request to have a valid API key. Or the other one that I have here is rate limiting. So I'm going to move this above that. So I'm going to authenticate the user first, and then I'm going to rate limit them. So for example, in this case, I'm allowing only 2 requests per 1 minute. So it's very easy to add policies to your requests, and you can do whatever you want down here with handling this request. Now, a quick note on this file also, this is your OpenAPI specification. This is how you define standard APIs. And this is what also powers our documentation. So the examples, as you can see here, I have defined that inside the request body of a post request that we have here, we require a prompt and a user ID, and I provided the examples, I provided the required fields, and also a response example that maps to this schema that I have created inside of my modules. Again, in this schema, I have this blog. This is just basically defining the shape of our blog posts so we can provide it to our documentation so the users of our API can understand what they can expect. Now, developers can come in and sign in here for an account. They're going to have an API key, which they can then use to talk to this API endpoint. So let's test this API endpoint. Let me go back to our route over here. Let me make this smaller. So I'm going to save the changes that I have made. Now, once this finishes running, it's now deployed, and I can go ahead and test my API endpoint. So as you can see here, this is giving me an example prompt and a user ID. Well, we are not passing any user ID here, so we're just going to test it with this example 123. Now I'm hitting this endpoint, and the endpoint is also there too, but I'm not passing in any authentication, so this should fail. So let's test this out. And as you can see, this is 401 unauthorized because we are not passing in any authorization header. Now, to create an API key so we can authenticate against this endpoint, you can go to your settings and go to your API key consumers. I've created a next app user and an API key, so I can copy this, going back to our files, to our route, to this specific post where we can test. I can just pass in an authorization header with a bearer token, and I'm going to paste in my bearer token. Now you can do this test from any API client such as Postman. It's easy that you get this test functionality right inside of your panel. So if I go ahead and now test, this should pass the test. Go ahead and call the OpenAI, generate the blog post, save it to our database, and then return back to me the blog post. So I'm using this API as an independent developer to generate some blog posts using AI and get the blog back. You can see we have the 200 OK result here, and we're getting our blog post back. Actually, if we go back to our application, we should see this blog post generated as well because we're hosting everything inside of our Supabase. Now, this is the curvature of Earth. We just created this. And once we click on it, we should be able to see the image and the content of this blog post. And this is how easy you can add an API layer or gateway in your application to expose whatever functionality you are having to other developers. You can furthermore add Stripe to this API, so you can charge developers per basis or per usage. But now that we have this API set up, let's just go back to our application and actually update our server action to use our API gateway instead of directly calling OpenAI or our Supabase. So inside of our application, I'm going to go in the app folder and create a gateway.ts file here. I'm going to copy some code and I'm going to explain what I'm doing. Now, I'm exporting the same create completion server action that requires a prompt. It's checking to see whether or not there is a prompt and there is a user. Up until this point, everything is the same. But instead of calling OpenAI or Supabase directly, all I'm doing here is getting the gateway URL. This is the same URL that it's exposed to you from here, from your Zuplo account, or in the Getting Started tab, you can see your gateway URL. I'm going to get that. I'm going to generate the endpoint, which is /v1 blogs. And then I'm going to send a fetch request to that endpoint with a method of post. I'm going to pass an authorization header because we need to be authenticated against this endpoint. I'm going to use the same API key I created earlier inside of the settings tab, the API consumer that we created. I'm going to bring this into my next app. I'm going to then pass in my prompt and user ID to my request body. This is what my endpoint requires. And this is going to give me a block back. If I don't have the block or if there is any error, I'm going to return this error object from my server action, just as I did in our previous server action. And once I have the block, I'm going to revalidate my index route or revalidate the cache, and I'm going to redirect the user to the generated blog post. Now let's go back to our form, and instead of getting this create completion from our actions, I'm going to import it from our gateway file. This is just exposing another server action that instead of talking directly to Supabase and OpenAI, it's just now talking to our OpenAPI gateway. And with this, if I go back to our application and go back to our homepage and refresh, let's go ahead and sign in. And let's go ahead and generate a new blog post about API gateway, this time through our own API gateway deployed from Zuplo. And here we go. We have the blog post generated with the image and the content, but this time through our API gateway. So going back to our homepage, let's review what we have done over here. Let me close all of the components here, going back to our application. So we created this app with the layout and the page. Inside of our page, we had our form, We're going to dive into the form for a second, but we are fetching blog posts from our Supabase backend and showing the cards down here inside of our form. What we had done here is we can bring this back in to check whether or not they have a prompt. So this was a client action. So from a high level, again, we have this form component with an input that takes in a prompt from the user. We protected this input or this form submission with our Clerk authentication using this signed in and signed out functionality or control component. So if they're signed in, they can go ahead and submit the form. If they're not, it's just going to prompt them to sign in and create an account if they don't have. And once they submit this form with an input, we're going to call this client-side action. The client-side action is going to check to see whether or not they have a prompt. We use this toast notification to show errors. And then once we do have the prompt, we're going to call this create completion function. This time we are importing this from our gateway. Inside of here, we're checking to see if we have a prompt and we have an authenticated user. Then we're going to call our API gateway endpoint with a post request, passing in some authorization headers and the prompt and user ID. We're going to get a blog back, revalidate the cache for the index route so that we can show that recently generated blog post, and then redirect the user to that individual blog post. Now, a critical point I want to mention here is that running AI generation for text and image is time consuming. So when you go ahead and deploy your app to platforms like Vercel, there is a limited time that these functions would run before they time out. So for the free account on Vercel, for example, this is 10 seconds. So if your server action or your API endpoints don't respond in 10 seconds, it's going to time out. Now, to solve this, if you're on Vercel, you need to upgrade to a pro plan where you can actually pass in another max duration more than 10 seconds. So let's go to the docs here. If we search for this max duration, you can see there's this route config option. You can export from your layouts, pages, or routes that changes the max duration of this specific server function when it's running. But another thing that you might notice is that, well, this is a route config segment option, which you can only export from your layouts, pages, and routes. And you might think, well, I'm just calling this function inside of a server action. So what do I do if I were to increase the max duration of a server action, which is an API endpoint, but we don't have access to that route handler directly to set this config option on that route? So for server actions, you need to export this max duration from the page that's actually calling this server action. So inside of our homepage, this is where we have this form, and from inside of this form, it's where we're calling this server action. So you can just go ahead here and inside of this homepage, export a const called max duration and set this to however many seconds that you want. And that's a wrap for this video, folks. It was a longer project where we learned about OpenAI models. We used Supabase as a backend and also as a storage. We used Clerk as an authentication or user management solution. We then created an API layer that sits in between our backend and any front-end consumer of our API. If you want to see more projects like this, AI related or not related, again, hit me up down in the comments. Now, some suggestions as to how you can extend this application. We can also create a get endpoint where developers or any API consumer can hit to get their own generated blog posts. You can add row level security in your Supabase. So when you are talking to Supabase, you can generate your own blog posts and only get back your own generated blog posts instead of getting everybody else's. And lastly, you can monetize your APIs by adding Stripe to the mix, where you can charge your API consumers on a pay per usage basis. I might create a video on this in a future video, so stay tuned and I'll see you in the next one. Bye-bye.